So we're going to go through the solubility assessment I set you. You attempted it pretty well, though some of the questions were pretty difficult and a few of you struggled with them. So hopefully this video will make things a wee bit clearer for you. So the first part of the question gives you some solubility information for two solids, potassium chloride and silver nitrate. The first one, as a lot of solubility questions start with, is just the definition. Though again, those is worth 4 marks. There is quite a lot of marks on offer just for remembering a definition. It is quite specific though, so you have to get these 4 specific parts. First mark is the mass of solid. Second mark is which saturate. Third mark, 100 grams of water. Last mark, at a given temperature. So again, all of that is in your booklet, but obviously it's just a lot to learn for your definition for the exam. Part 2, just a wee 1 marker, state the general trend in solubility of a solid as temperature increases. That's just a wee bit of recall. So for pretty much every solid, as you heat up the water, it's going to be able to dissolve better. So you just need to say that the solubility increases. And then in part C we come to a fresh calculation. So it says calculate the mass of silver nitrate, which would crystallise when a saturated solution containing 40 grams of water, 40 degrees C, is cooled to 20 degrees C. So these can be quite tricky, these questions, because there's lots of information in the question, and you often have to do a wee bit of like ratio work to scale numbers up and down. But let's just look at what information we have been given. It's silver nitrate, so obviously I know from the table above it's going to be from this row here, the silver nitrate. Which would crystallise, so crystallise may be a bit of a strange word, basically remain deposit, so it's going to cool down and some of it's going to turn into a solid at the bottom of the beaker. When a saturated solution, remember the word saturated means it contains the maximum amount that can be dissolved at that temperature. There's 40 grams of water in it and it's at 40 degrees C cooling down to 20 degrees C. So I've got 2 temperatures there. So what I'm going to start with is working out what the solubility values are at those 2 temperatures and write them down here. So solubility at 40 degrees C, according to this table, is 311 grams per 100 grams of water. And then when you cool it down to 20 degrees C, according to the table, it goes down to 216 grams per 100 grams of water. So I've done no thinking so far, just taking numbers out of the table there. So now we come to the bit where we have to manipulate kind of the numbers here. So the normal kind of strategy of these questions when you're cooling something down is you subtract the solubility values. That would be true here, but these units are out of 100 grams of water. The solution I've got in the question is only 40 grams of water, therefore I need to adjust these values to make it work. And you can absolutely adjust solubility values, you're allowed to as long as you do the same thing to both sides of the unit there. So I need to get 100 grams down to 40 grams, I'm going to do the same thing to both. There's no kind of quick or clever way to get down to 40. I'm just going to divide by 100 because I'll make it for 1 gram, and then times by 40 would make it for 40 grams, and do that for both sides of it. So we're going to do 311 and divide it by 100 times by 40 gets me 124.4 grams of silver nitrate will dissolve in 40 grams. Same thing for the 216. Divide by 100 times by 40 gets me 86.4 grams per 40 grams of water. So now I know that at 40 degrees C, this silver nitrate dissolves 124.4 grams in 40 grams of water. However, when I cool it down, it's only able to hold 86.4 grams for every 40 grams of water. Therefore, some of it's going to deposit out. That's what I've been asked to calculate. To work that out, I'm just going to subtract those 2 values from each other. So 124.4 minus 86.4 gets me a final answer of 38 grams deposited. On to part B. So it's a graph-based question. Gives the solubility curves for 4 different substances A, B, C and D. So it's separate to part A. So it's all plotted in the graph there. Which substance is most soluble at 10 degrees C is the first question. So I'm looking along the temperature axis, 10 degrees C. I'm just trying to find the highest line at 10 degrees C. That's this one, so it is just D. At what temperature do substances A and D have the same solubility? So there's my A line and there's my D line. I'm trying to find the point where they cross. They cross exactly here. Read down to the temperature axis because it's asking what the temperature is when they have the same solubility. And that would just be 56 degrees C. At what temperature would 3 grams of substance C saturate 10 grams of water? So there's only one mark this question, but it's a wee bit tricky. So we're talking about C, obviously. It's asking about what temperature would 3 grams saturate 10 grams of water. If you look at the axis here, this isn't about 10 grams of water. This is about 100 grams of water and how much will saturate it. So I need to kind of scale up this value here, because the temperature at which 3 grams will saturate 10 grams will also be the temperature at 30 grams saturates 100 grams of water. Remember, these units kind of scale up and scale down absolutely fine. So I'm looking at the temperature at which 30 grams will saturate 100 grams of water. Basically what that means is at what temperature is the solubility 30 grams for 100 grams of water for C. So if I look along my C line, I'm trying to find the solubility of 30 grams per 100 grams, so 30 is here. Reading along that axis, my point is here. The temperature at which 30 grams dissolves in 100 grams of water, and also where 3 grams dissolve in 10 grams of water, will just be 70 degrees C. Final part of the question, kind of a tricky end to it. So we're still talking about A, B, C and D. We've got a table of data for them this time. So it's about different types of mixture that involve A, B, C and D at different temperatures with different amounts of water. So for example, A's got 5 grams of A and 10 grams of water at 70 degrees C. So all these different combinations of solution with those 4 substances. First question we have to work out is which of those mixtures, so that refers to the mixtures of A, B, C and D, 1 to 4, are actually saturated solutions. There's no kind of trick way of doing this. Basically, you have to work out what these values are corresponding to the solubility graph on the previous page. So if I'm trying to compare these two things, I'm looking at my values here with my solubility curves over here. Again, the key difficulty is this solubility curve or solubility curves are in grams per 100 grams of water, but we don't have those nice units for my table here. So I'm going to do a wee bit of work, just roughly working out, is what would these values be if I scale them up or down so they're out of 100 grams of water. And again, key point with solubility, that's a very common thing to do. You're quite able to scale these values up and down as long as you're doing exactly the same thing to both sides. So if you double the mass of water, you double the mass of the substance and so on. Just trying to get them out of 100 grams of water so they match this graph. So the first one's very easy to do. It's 5 grams in 10 grams of water, so that's the same thing as 50 grams in 100 grams of water. For this one, 180 out of 500, I'm just going to divide that by 5. So if it was out of 100 grams of water, it's going to be 180 divided by 5, which I should be able to do in my head, but I can't. 36. So 36 out of 100. This one's out of 25, is going to times by 4 to get everything out of 100. So 2 times 4 is 8. And then this one, I'm going to divide by 2.5 to get that out of 100, and divide 80 by 2.5, and that should be 32. So what I've done there is just adjust those kind of solubility, or not solubility values, adjust what I've got in these solutions so that they match solubility values in the graph on the page before. So now I'm looking at which ones are saturated solutions. So again, the key thing I'll look at is the substance and the temperature, and then compare it to the value I've got. What I mean by that is if I look at A first, that's mixture 1, which is made up of A. It's a 70 degrees C. So if I look at 70 degrees C for A, I get a solubility value of about 48. If I've read that right, yep. So after 70 degrees C, A is able to dissolve 48 grams of A in 100 grams of water. In this mixture, I've got 50 grams of A in 100 grams of water. Therefore, it's more than saturated. In other words, it's holding as much A as possible. There's going to be a wee bit kind of sat at the bottom of the mixture, it's the bottom of the beaker. So that actually is saturated. B, I'm going to look for 40 degrees C for B. So look at my B curve, going to go down to 40. So that is here. And that's more or less exactly 40 grams per 100 grams of water. However, if I look how I scale my value, for mixture 2, it's equivalent to B there being 36 grams of B in 100 grams of water. That's less than the 40 grams it can hold at that temperature. therefore it's not saturated. Looking at C, so I've got 10 degrees C for C, so let's write down this part of the graph. Sorry, here. And at 10 degrees C, it's roughly 5 it can hold. If I look at my scale values, it's able to hold 5 in 100 grams of water. What we've actually got is 8 grams, 100 grams of water. Therefore, it's dissolved as much as possible at that 10 degrees C. Therefore, this is saturated. Final 1D. So I'm looking at 30 degrees C. And we're going to about 36. So at 30 degrees C, D is able to hold 36 grams of D in 100 grams of water. In my scale value, we've got 32 grams of water or 100 grams of water. That's less than what it can dissolve. Therefore, this is not saturated. So it's actually quite a lot of hard work for just 2 more questions. The 2 saturated mixtures are actually 1 and 3. Final part of the question. On cooling a saturated solution of B containing 50 grams of water from 60 degrees C to a lower temperature, 6 grams of solid were deposited. Determine the temperature at which the solution was cooled. So again, this is quite a tricky question, but the key strategy is just try and get as much information from the question as you can get. So first thing is, this is about B, so I know that's one substance I'm looking at. It's got 50 grams of water, so I'm thinking already I might need to scale that up or down from 100. It's at 60 degrees C and it's being cooled. Now this one's a wee bit different. It's not actually telling me what temperature it's being cooled to. I'm going to have to work that out, but it does tell me how much has been deposited to determine the temperature at which the solution was cooled. So first thing I'll probably do is actually look at B and look at 60 degrees C to work out what the solubility is for B there. So at 60 degrees C, I'm going to have to use my graph again. I make the solubility to be 46 grams per 100 grams of water. So that's the solubility we've got. What I'll probably do here is just convert that now to make it out 50 grams of water, because my solution has got 50 grams of water. It's not too hard to do. I'm just going to divide both sides by 2. That's 23 grams per 50 grams of water. So now looking back to the question, I've got a solution. It's saturated, so therefore it's containing 23 grams of the solid in 50 grams of water. I've cooled it down and 6 grams were deposited. So the implication of that is most of B is still dissolved, but some of it's dropped out to the bottom. So if it does have 23 and I've lost 6 grams of it because it's deposited, the amount that's still in the solution must be 17 grams in that 50 grams of water, and that's when we've cooled down to this lower temperature. So the solubility at that temperature must be 17 grams per 50 grams of water, because that's the maximum it can hold, because it's dropped out that 6 grams it can't hold anymore, and that's what's left behind. So to work out the temperature that is the solubility value for, I need to convert back into out of 100 grams, because that's what my graph units are. They're going to times it by 2 again. So in 100 grams of water, my solubility must be 34 grams per 100 grams. So now I just need to go back to my graph and work out what temperature is the solubility of B, 34 grams per 100 grams. Use my B curve. 34 is about here. And it's pretty much exactly on 20 degrees C, giving me my final answer. So I'm not saying that's easy at all, but it is just scaling up or scaling down your solubility values. And the key kind of strategy here, read really carefully what they give you in the question. It should give you plenty of hints about how you approach each question.